Now this came up in class, and somebody asked, okay, if a statement and the converse are both true, that means if this one and this one are both true, then we say that P is equivalent to Q, i.e. that P is true if and only if Q is true. Okay, this statement is written as, well, here's the statement, if P then Q, so here's a statement, and the converse, well, here's the converse. Okay, so we have the statement and the converse. If these are both true, then we can say that, well, if P then Q, the arrow goes this way, and if Q then P, the arrow goes this way. If they're both true, then we can say that the two statements are equivalent. We can say that P is true if Q is true, which means if Q then P, and you have to look at that translation, and also that P is true only if Q is true. Now that means that P is true only if Q is true, so look up here. Now let's not go back to the truth table on it. That's more of an explanation than I want to lay on you without room to write. Okay, so let me back off on that. So anyhow, that's what it means. Now this can also be written this way, sometimes is, can also be written this way. This means is equivalent to, this means if and only if, basically, and this means is equivalent to. That one implies the other. The picture, well, if P is equivalent to Q, then the P circle has to be a subset of the Q circle. But if, where is it? If this is true, the Q circle has to be within the P circle, or subset of. Okay, well, if the P and Q sets are both each a subset of the other, what does that mean? That means that they're the same. So that the circles here is a circle for Q, and the same circle applies to P. There's nothing in P that's not in Q. There's nothing in Q that's not in P. The two are equivalent.